There we go. And we are live. Yeah, every time I think, I should set the time to start the stream later. I'm always like, nah, it'll be fine. I'll actually start the stream when I think I'll start the stream. Oh no, I'm 15 minutes late. Who could have ever predicted this? No, this time, my excuse was I was finding batteries for my right controller, and there are none in the entire house, so I had to steal some out of a Wii remote. And of course, you know, I use hand tracking for the majority of the stream. But to actually position my monitors and navigate the menus to get to the point where I'm using hand tracking, I do need actual controllers. And one of my hot takes, I actually really don't like hand tracking. Like, I kind of despise it. That is one of my actual VR hot takes. There's not enough user confidence in... I'm gonna not use buzzword. When I use hand tracking, I don't feel like I can control anything at all with any degree of certainty. That's why I don't like hand tracking. But yeah, I have done a fair amount of work off of stream, so the main thing that is different is we're back to just putting the name of types into function arguments. Like this. That is the main improvement. But Brane, work with me here. Yes, so the main improvement, that's like the only visual difference, is now instead of putting functions into here, instead we put just values. And it's not a specific data structure that we put into here. It's actually just a regular value. So we're putting a number value, not the value number is actually a number, but it's not any number. It's a number representing any possible value of a number. So this isn't a type object as you would usually have in other like metaprogramming systems. Instead, it's just a straight up number. But it's like a speculative number. Which works a lot cleaner, like significantly cleaner, than you would normally get. Or it works significantly cleaner than the route I was going down with constraints of like, let's just put a function into here, and that function can also mutate the value to like do typecasting and whatnot. And no. This is now just a value, and it's a speculative value. And if a value is passed into this function, that can be contained within the possible values of this value. Like, if this is a speculative value, and the value passed into this is either a more specific speculative value or an actual resolved value that is one of the possible outcomes of the speculative value, then it fulfills the type condition. Which sounds pretty... like, that sounds pretty crazy, but it's not that... I want to say it's not that hard to wrap your head around once you actually, like, see it in practice, as opposed to just, like, me blabbering about it. But I think it's going to make for an incredibly easy to use metaprogramming system and whatnot. So, what I need to figure out is there's a couple things we could do on this stream. One is jump straight to trying to get the compiler pipeline working. The second is function definition validation. So what we would do here is type check but not run the function. And that's what this does. Well, it can half run the function. The problem is, for this to work, we need to define exactly what our output values are. Like, what are we expecting to be returned from every single API function? And that includes standard library functions. Right now I have add returning in any type, or it is defined to return in any type. What it actually returns is a number. Well, in its definition I have it set up to return any. And what this function definition should do is we can optionally define a return value here. Like I could say number like this, and then this will enforce 100% that we do return a number value. Or rather, that the output falls within the bounds of number, and always falls within the bounds of a number. But the output would still behind the scenes be more specific than a number. We would get the actual possible options of number. Which that's something I should account for, is if we return options and we want to return number, if we check that every single one of the options fulfills the constraint, then it should be valid, even though it is technically an options value, not a specific value. Anyway, I'm getting sidetracked. Where's water bottle? There's water bottle. Okay, then the other thing that we can do today is implement standard library. And what we would do here is start adding in tons of intrinsic functions. And the final thing that we could do today is implement build output /runtime. And what this would do is make it so we actually output IR and then are able to run that IR. And then as a quick quick easy, we could implement pipeline syntax. That is one thing that is one thing that we could do. So, thinking about our goals of just, like, I very much want this to be, like, a very easy to use language, very easy to build language, and have this up and running quickly. But the most important thing before all of that is, like, that it runs very fast. Otherwise, I could just ship the current version of the language I have right now, and it would actually work. The language is currently, in its current state, implemented enough that I could use it as a coding language for the engine. Like, it is ready enough in this kind of crappy state. But it would be the slowest thing on Earth. Like, this would be so slow because we're doing runtime type checking. Which means we're doing like a possibly huge pattern match check every single time we call a function, and that's like, that is unacceptable. Entirely unacceptable. For something that needs to be fast. Now, this is a compiler, so it needs to be quick, but not runtime quick. It needs to be fast enough to be able to do a hot reload in like 2 seconds maximum. But that's the thing. It needs to be 2 seconds for a running of everything once, instead of, you know, less than 9 milliseconds every frame. Big amount of difference between 2 seconds and 9 milliseconds. For reference, 9 milliseconds is, I believe, 100 FPS. 144 FPS, I believe. So 1,000 divided by 144. Okay, yeah, we actually only have just under 7 milliseconds to work with if we want to support high-end headsets, which we do. We very much do. Now, you're probably going to be running at 120 hertz most of the time, so that's 1,000 divided by 120, so that gets us closer to 9, but that's still 8 milliseconds. Hello, numbers username. But yeah, so this is how fast our scripts need to be. Everything needs to run in that time. So the current, well, yes, structurally, we would be able to use the current version of the language as the language of the engine. We need to make it faster, much faster. And we can do that using either LLVM or crane lift. And currently, I have an LLVM backend set up. The thing is, and crane lift is the other one we could use, which is what they use for WASM time. And the benefit of LLVM is LLVM compiles super fast code, but I don't know how slow LLVM code generation is. Let's see this measuring. I want to see this. Can I see just a graph? I'm not smart enough for this. How do I see the research paper? Language compiler has negotiable compilation cost. It produces code from AST in less time than it takes to construct the AST. Okay, so yeah, Crane Lift is very fast as a JIT compiler. So they say an order of magnitude faster. How fast is an order of magnitude? Is that like 10 times faster? Each division or multiplication by 10 is called an order of magnitude. Okay, so roughly 10 times faster. Then LLVM. And for 10 times less code performance, of load performance, the end result of the code is only 14% slower. So yeah, I'm gonna have to implement a Crane Lift backend for Quest for sure. And it might make more sense to just use a Crane Lift backend from the beginning. I really want to use an LLVM backend on PC because then it's like you have 14% more bandwidth. At the scales of 9 milliseconds, 14% is a lot. That's like an entire millisecond in there that you get extra to work with. But then when you're actually loading worlds, it would make loading worlds 10 times slower. At least for the script side of things, which I don't imagine scripts are going to be massive. They might be. Hopefully the output build result is optimized to the point where it's not huge. But yeah, when I build a quest, I'm going to need to build a Crane Lift backend. Right now, though, let's not worry about that. What we're going to worry about right now is that when we run a script, so right now, if I were to do cargo run example scripts test b script, this is supposed to be our compiler step here. So right now it's just optimizing down to a constant. But if we wanted to allow for runtime output, we need to account for runtime values. So we need a way to basically reduce the output of our program to a runtime output. Now, right now, this is what we have as our intermediate representation. And we need to figure out how to go from that output to this output. And the approach that I was currently considering was what if when we evaluate code here, whenever we get a speculative value, another term for that is a runtime value, so a value that only exists at runtime. So if we were to evaluate the pipeline foo, which takes a number as input, this would actually fail because number is speculative, so we don't know if number is an integer or if it's a float. Well, more specifically, what I mean is that the exact bit width and so F32 is more what this is going to look like. So pipeline foo F32. So this 32-bit floating point number, this tells us what the storage type float and bit width 32 this type is. But it does not tell us the actual number value, so it's still speculative, but it's resolved enough that we can compile with it. Okay. So first step, before we can get to any of this, is in my spec document, the way I defined just switch notion spaces right now. There we go. Somewhere in here, I defined compilation. And when I defined compilation, wherever it is, when compiling the program, the root script of a compile unit is ran, resulting in an object representing the structure of a module with function bodies as runtime value objects. They'll be compiled into intermediate functions. Then all pipeline bodies will be compiled as runtime functions. And a compile unit containing all of those emitted. Or you get a ton of errors. So I did word that a little bit weirdly. See, then all pipeline bodies will be compiled as runtime functions, and a compile unit of all of those will be emitted. So, thinking about this, the way that I want things to work is linking what is exposed from this module, from one module to other modules. See, we want to expose functions for static linking in the case of utility libraries, but we want to expose directly compile pipelines and expose those as dynamic we want to directly compile pipelines and then have those linked by the runtime, instead of that being a compile time thing. Because if you think about it, pipelines call pipeline stages. Those pipeline stages live inside the pipelines of this module. So it doesn't make sense to export any of the actual pipeline stages. We just want the ability for other modules to call this pipeline. But with functions, you are calling those from the body of your pipelines, therefore it makes sense for that to be embedded within the pipeline, instead of statically compile it into another module. Static. So in other words, functions are always statically linked, and pipelines are always dynamically linked. Okay, so is an object. The members of that object represent namespaces. the members of the object can be constants, objects, or all, and we're gonna say everything but pipelines on said object are exposed as constants to other modules. Everything but pipelines on said object. We're gonna say that object are exposed as constants to other modules, but pipelines are compiled pipelines are truly compiled, and then when exposed to other modules, instead they'll be given a reference or an ID that they can use to start other pipelines. Think about it. Do I need the ability to label numbers? Like the type of numbers? Do I need to have the ability to blatantly label all value types? I don't know. Because if I'm thinking about like pipeline ID, that might be just a number, that might be a string. But the thing is, I don't have a way to differentiate that from any other number or any other string that could be passed to those things. So I might have to redo the value system to support more fine-grained labeling than just... Well, actually, I can label objects. So we can do an object with a value, and have that object be labeled pipeline ID, and then have a single member that is value. And then we can also put like utility functions on it and whatnot. Okay, that makes more sense than being able to label numbers with a name. So that is the direction that we'll go. Instead, they'll be given an ID that they can use to Okay. So now what we need to do is... first define the syntax. Of pipelines. No. I'm gonna put it right underneath function, so we're gonna call this a pipe expression. This is gonna be token pipe . Sorry, I have yawning today. But the thing about pipeline expressions is I'm not sure what grammar I want them to have. I think about what is the purpose of a pipeline. It's not one function, it's multiple functions put together, and pipelines will never be called as functions. They will always be dispatched. If I think about it, pipelines could be defined as an object, but we could potentially make them, well, we will make them a lot easier to define with static validation and whatnot. They're a core part of the pipeline. They define pipelines, but when we get down to the syntax of it, what do they look like? And what do we return? What do inputs look like? And how do we signify that we're starting a pipeline? How do we signify that we're ending a pipeline? I have a potentially crazy idea. So one thing is, I'm not actually sure I'm a fan of FN defining functions like this. I might want to go the more JavaScript-y route of just like closures. So if I look at this match statement, this is pretty cluttered at the moment. Like this is super cluttered at the moment by a ton of grammar that doesn't necessarily need to be here. What I could theoretically do something closer to that. Like a lot closer to this. Now it only has one argument, so then you get into like it looking like this. This is what a Rust match statement would look like if you selected types like this. Rust match statement would actually look like this, but if you had an actual value and you wanted to label, no, it would never look like this. Anyways, this is what it looks like right now, because you need to put functions in as the values for each branch of the match statement. But I want this to be cleaner, and the cleanest way to do it right now would be to use JavaScript style function syntax. The problem with JavaScript style function syntax that the arrow operator is now exactly the same. We don't want exactly duplicated function syntax like this. Which is why I started going down the rabbit hole of like, oh, what if it's just like the function arguments that define when it goes down that route. It honestly makes a lot of sense in this instance. So yeah, let's change our syntax so that match statements just accept a list of functions, and then the input of those functions is the actual could have that. I could, but I don't really want to mix symbols. Actually, let me just make sure that, so C#. So we have C# closures. Can I get an image of the syntax, please? I might actually want the AI mode. Here, can you, thank you. Equals arrow. In JavaScript, it's also Well, they just say function as an entire word. I kind of like just saying just fn if I am going to prefix it with anything. But they also use equals arrow, and I want to stick with the standard for that's how you define closures. Here, 1 second, I need to open the door. Right, you could close the door. Yeah, the printer isn't my room. Occasionally I have to get up, unconstruct my setup, and go lock the door, which is inconvenient. Hello. Okay. Here's setup again. So I think if we want to keep the same exact pattern but have our syntax be readable, we will just switch to this. And I think we'll keep the curly braces for now, and then just make the arrow explicitly necessary. And also change the syntax of match statements to work that way. Okay, and then for test Brane script, that would change it to look like this. So if we define a pipeline like that, how do we define the stages? Syntax for function definitions is interesting. I wonder, does it allow for you to rename a function by assigning it to a new identifier? So, even more than that, the functions don't have names. Functions themselves are values. So, this is a value myAdd that is set to the value of this function. So, you could even have, like, if I set up a clone function for functions, you could clone and have like the same function in multiple different labels. So this is, I guess technically it's not a variable, it's a label if I'm going with my own definitions of things. But we're labeling this value as myAdd, and then we are consuming the value myAdd here in a call operation, and then we're labeling the output result1. If I want to be super accurate to the terminology of what's going on here, since I haven't done shared values yet, so it does consume the function. What if I did pipelines as an array of functions? Each function accepting the translated output of the last one? Maybe? I did kind of want to have the ability to have pipelines look like this. You know, you just put in your code, and then there's a minimal amount of syntax for getting to the next stage. So we have the inputs, and then we have possible out, input, output, and we want to put the output here because then it's, well, yeah. Because then it's an easy, like, oh, here's the definition of that thing. And then here are the inputs, and then here are the outputs, and you don't have to scroll down the 1,000-lined pipeline to see what outputs at the very end. Instead, you can just directly verify it. And the other thing I want to do is to be able to insert other pipelines directly into a pipeline. We have pipe int and then a function definition. If we just like we'd be so cursed, but we could do something like this where it just actually looks like a pipeline. So you'd have the original input of the pipeline going directly into see, where do we define the actual return value for this pipeline? we would have pipeline returns number, and then here's the inputs. I don't know about that. That is super confusing. See, behind the scenes, pipeline is basically going to be a structure. They'll probably treat it differently by the runtime. And we are... Don't tell anyone, but the way that Brane script is going to work is kind of similar to pipeline. Vulkan. Not pipeline. Is kind of similar to Vulkan, to where, like, all actual things are executed by the runtime and not by the actual code. Like, the code does the work of choosing what to do, and then it tells the runtime what to do, and then the runtime takes care of actually doing it. I just need to decide what I want my pipeline syntax to be. Because before, when we were going the traditional language route, I was like, yeah, we'll do pipeline, label, args, output, square braces, and then curly braces, then code, in here, and then you could set exactly what you want the arguments of this to be explicitly if you wanted to, and then that would constrain the output of this pipeline stage. And these args and this output would constrain the input of the first pipeline stage and the output of the last pipeline stage. I'm trying to consider, do I want to keep the same syntax, just with the lack of the label, with the braces? In fact, pipelines don't necessarily need to be... Well, no, I do need some way to tell the runtime, like, hey, this is being exported as... Or tell the compiler that, hey, this is being exported as this specific thing that needs to actually be compiled, and then exposed to the runtime. Exposed in the runtime. So... we do need it to be a specifically labeled thing, not just a generic structure. Except it could be an object. It could be an object. There's not really a way to define order of execution if it's an object, other than the fact that yes, I do store member order. So it could be pipeline, and then equals pipeline block 1 is equal to a function. Block 2 is equal to a function. It should be an object because OOP is the only correct option for every programming related problem. Okay, yes, we're not doing objects. Thank you for convincing me. I just don't want it to be an overly verbose thing, and like closures. This is like relatively clean. There's only a maximum at the moment. We have mandatory 1, 2, 3, 4, 5, 6 characters that you must type. Well, technically you need to type in function. Yeah, I'm not gonna overthink it for now. We'll figure out the correct way to do this along the way. Wait a second. Pipelines do do pipelines need to be labeled? Well, we have our output object. See, technically, because we can return anything from a script, we can return an object or we can return an actual constant value. Now, if I want to enforce that it has to be an object, then we can say pipe test is equal to pipeline, and then this is our runtime label of the pipeline. That is easy. Because for, like, debugging purposes, it's really nice to have things named correctly. Like, really nice to have things named certain ways instead of just being like pipeline good. Just how it's going to be handled behind the scenes, but be really nice. The pipeline had a certain path, and I guess I could resolve the paths of things by module name and then member name. Maybe I'll just define that in the spec now. the naming convention will be module dot member path. Objects and just module name. And just module name. Or when only a single thing is emitted from, only a single value is, single non-object value is emitted from module. And we're going to define this pipeline as oh dang, I don't currently have value hoisting. So I don't currently have a way to go from technically, this should be a valid pipeline right here. Actually, let me get this even more spicy. Yeah, this should be a valid pipeline that does this, then this, and then this. I'm just thinking about how do I simplify the syntax of this? Actually, explicitly, for this version of Brane script, We are just trying to get it working. No simplifying the syntax. So, this is currently the very verbose final form. Outside of maybe making it so that we can return pipeline definitions. Like that. And the square braces make it a pipeline instead of a closure. I kind of like that. But I also like the explicitness of the pipe keyword there. But I also like removing a tiny bit of visual clutter. So, yeah. No explicit pipe. We're gonna say this is the function expression. But then we also have pipeline definitions that are this, but I forgot. This needs to be then token expression clone or not, like that. Oh no, you would not be able to internet bully me. See, I was already Rust brained, but I have never been object-oriented brained. Whenever I look at the way that object-oriented wants me to do stuff, I'm like, that's so much, like, you want me to encapsulate everything? Like, everything? Like, I can just feel the runtime overhead creeping up onto me. Like, I'm so much of a micro-optimizer that the instant you ask me to do anything where it's like, oh, it's more work for you, and it's more work for the computer. So it makes it slower, it makes you slower to code, it makes the computer slower to run it. Why are you asking me to do this then? Like, there's absolutely no point to this. Oh, but there's less chance of errors. Well, let me fail faster then. But it's not even like less chance of runtime errors, it's less chance of like design. I don't even know what the point of like pure object-oriented programming, if I'm going to be completely honest, is. Now, message passing architectures I can get behind, like Elixir. That's kind of like a different interpretation of object-oriented, and I love that interpretation of it. However, OOP as like the way Java or C++ does it is a no. It's not even an addiction to data types, because like I've heard a lot of criticism of Rust that it's like, you know, you don't get anything done because you're too busy like constructing your perfect web of traits. But yeah, I can see myself sometimes doing that, but like that's because Rust, it's fun. And it has no runtime cost. It's a little bit of compiler time cost, but I don't know, there's so much more structure to the way Rust traits work than object-oriented traits. Well, it's not even boxing everything into its own data types. It's the fact that it's the inheritance part of object-oriented programming I really don't like. Like, the encapsulation stuff can sometimes be excessive, but the way that, like, when you actually start diving into object-oriented programming, what they always want you to do is like do super nested. Yeah, we have this one feature that we're gonna reuse, and now everything inherits from that. And then we have this other tiny bit of extra behavior. So we now parent that, and now we parent everything from that. And see, I only want the 50 lines of actual code. That's the thing. Expected tuple vec string option expression. Found tuple. Let me just. When I do this. Ords is unknown. Ah! See, each layer deeper. Further scopes it, right? Oh wait, was this valid? No way that's valid. It's lagging out. There's no way that's valid. You'll see if you code a node graph system correctly, you can draw from an existing list of functions programmatically, but yeah, node systems can be a ton of work to maintain. Why? Okay, did this just nuke my LSP? I think this might have nuked my LSP. Oh, nice. Well, how did you enjoy C++? To be fair, I still like working in C++. I just don't use half of the features. That's how it be. Let's see. Let's just explicitly say we're not using this. Okay, so that is valid. I did not trust it at all. But apparently, this is valid. Okay, that's what went on there. So along with construct function, let's also create a new expression node, which is construct a pipeline. So return parameters, return value type, and then segment functions. Then I'm just going to keep this as a to-do for now, and we'll print it when I actually need it. then I bet... Yeah. Evaluate. Now, no longer... is exhaustive. Alright, and that at least gives us something to work with for the parser. And for the moment, this is just going to be function expression. Separated by commas. And that should be valid to parse that. Then finally, I just want to fix up the match expression. Hello, how's it going? Here we don't want to do expression anymore. Instead, we want this to be just a list of functions too. Instead of expression, then ignore. We just want to be. Why do I double clone this? Then match, we're going to slim this down to just be one expression. Then here we'll have a problem with this. this drastically simplifies this match statement. Then in here, we're gonna do branches push function. Let's say if func rams length is not equal to 1. Actually, I'm gonna swap the order of these just because it makes more sense. Expected match can only accept single parameter functions. Or can only match on single parameter functions. Then the doing condition, we do branch rams 0. Type. So now we match on the function parameter, and then we call the branch with the single condition. So this takes care of all those issues of me not actually checking to see if functions had the right parameters or not. Here, let's go through workspace error lists, expression, balloon. Okay. And now I believe if we do match test, okay, yeah, match test is working with the changes to the runtime and parser so that this syntax works instead, which I think is But this is potentially cleaner. It's potentially cleaner. I do kind of want to go all the way to, like, this level. Those parentheses are gonna bug me. Moving forward, because I told myself I would not focus on grammar of the language. We would code the language. That, however, was a purely grammatical change, but it made sense because I was changing the grammar of other things. Right now we are working on grammar, but not a ton of grammar. The optional parentheses is a convenience grammar thing. We don't need convenience grammar things right now. That was a necessity grammar change. Okay, so now if we switch back to checking the test Brane script, we will get a problem of parsing expected opening bracket at 131, expected minus or digit 131. Character 131. Where could that be? I need to add actual printing of error support. Because I have no idea where slice. Where that slice would be. Found opening bracket, so it's one of our opening brackets. Okay, I'm gonna edit the... Oh, I have the same thing open on both monitors. So we're going to go to the parser. We're gonna label expression define call added label as expression. Expected I label it and it goes expected identifier. Found open parenthesis. Wait a second, do I still have... Wait a second, I didn't add pipeline. That might be why it's bugging out. Except I feel like we should be getting an error at the square braces. Yeah, I need better error reporting. There. At the very least, what we can do is print out the line number, because that will tell me line character. Rich, and then this has the span. Which this is what's getting output. Let line char, or we'll say line and then C equal input. Dude, does this count as one? Yeah, it does. Okay, I'll keep that in mind. Input iter document. The elements of the container. Chars. Well, chars is an iterator. And we're gonna fold this into... Actually, no. I'm gonna say dang, I spent too much time trying to figure out how to do a fancy version of this. I completely cooked all my brain cells. 4C in document stars. I'm gonna say if count is more than or equal to the slice as slice. Yeah. No, not as sliced. Span. We need the span. Oh, it's a vector of rich errors. Oh. Yeah, I'm done with doing fancy things. I just want this to work. Indeed you did. Okay. So if this is more than or equal to the start, we break this. Otherwise, we do if C is equal to a new line, then line plus equals 1, C equals 0. And we're going to do line starts at 1. Else C plus equals 1. Oh. There we go. Okay, we should get line numbers now. With my very badly written code. There we go. Expected ident. That is not formatted correctly. Okay, 1515. That seems suspiciously like the same number, but we'll go with it. Line 15, character 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 1515 is in fact an identifier that it claims it to be, which is that one, which it was not expecting. I was expecting an identifier. Does structuring... This should be looking for a structure right here. So why is it looking for an identifier? Like, even if... Like, even if this had mistaken this for a... whatchamacallit? Like, for a structuring statement with 2 as the type of the structure to be created, it still wouldn't want a label here, would it? Unless it thinks that I'm trying to create a destructure statement. In which case, this is completely wrong. And it shouldn't even be expecting a label statement here. It should be expecting an expression statement here. But that is a good example of, like, you know what, maybe we should put separator statements in here. So because there's a square bracket on the end instead of a curly one? No. There is supposed to be square brackets here. It's supposed to be syntax for a pipeline instead of a function, and the difference is square versus curly. I was gonna do like a pipe like identifier, but I'm currently split on... It's already incredibly verbose. I want to cut down on like exactly how much stuff is there. We look at a structuring statement. It's label definition separated by token. It's just... That is expression. So should be expecting expression. So maybe... Let's see, do I have expressions labeled as expressions when I define expression? I do. No, I want to put it back on the bar. There we go. Expected identifier. So it doesn't look like I labeled anything. We labeled expression. We did not label identifier. Interesting. Let's also do pipeline definition as one of these. Maybe we do it after the match statement? Or before the match statement? Seems to be a little bit of confusion in like the trait system. So let's see, this is one's label statement defined here. Yeah, it's this map statement. Use the one from the parser trait, not from the input trait. Oh wait, is the width the first argument? No, it's not. Label, then the value. So this should be string optional expression, then an expression. That is valued. That is the correct value. option, and then a string reference. Another string reference? That's expression. It really wants this expression to be a string. What is this? This is Rust. Which for some reason is broken at the moment. My traits are suddenly bugging out. I kinda don't want to include Chomsky Prelude anymore. I kind of want to just directly include parsers so I don't have all these weird trait boundaries. Trait mismatches. Still expects that to be a string. No, wait, I don't want that to be mapped with. That might have been my problem. Or at least one of them. Yeah, same error. Want a string option there. Expression does not return a string reference, though. It doesn't. Expression labeled map and we return E. It will just be like, hey, we are returning an expression. Not a span. An expression. Wait. This is expecting one more thing. From ident? No, ident is just a string. Def token equals expression. Expected closure signature. Run optional. Then another string. And then an unknown type. So if I did this, would that be valid? No. Well, it was compiling, and now it is very much not compiling. I have no clue where it's getting these values from. Okay, let's look at this. So, expected closure signature, a tuple that is a tuple of another tuple and string, and then that tuple in there is string option. So I'm guessing this could still be an expression, but for some reason label ident is returning something weird. So let's do just a map statement on here of label type value, or just value. So that we can just say v here. Let's just type guard this of, this is very much a string, and then an expression. I forgot to make this then ignore. I forgot to make this then ignore. I am dumb. Anyways, what was I gonna test? Right, if it parsed. So now, at 1515, it found this and expected an identifier. That's what we were debugging. I'm guessing this is what identifier is. I wonder if I can label stuff with context. That's Chomsky span. I don't want to include this span tree in here because then it's, or rather no, it's input that I don't want to include. In context, annotate this error indicating that it occurred within the context node by the given label. A span that runs from the beginning of context up until the error location is also provided. In practice, this usually means adding the context to a content stack, similar to a backtrace. And is there a way for me to print that out? So I can know what it's trying to parse. Iterator, which pattern, simple span. does not implement debug. What is a rich pattern? Specific token, a labeled pattern. Does this implement debug? Yes, it does implement debug. So let's actually do map all of these to because they do implement debug. Zero to string. Don't care about the span. Just give me the name of what we are trying to parse. Here we go. In context, nothing. Ah! Okay, we are now going to this a destructure. Why are we not relining this? Oh wait, we already labeled these. No more labeling required. And then item. Expected label. So now, with all of that, expected function definition. Oh, there we go. Found M at that expected function definition or closing brace. Okay, I actually know what the problem is. The problem is I was going, oh, I should be able to do labels that can be function definitions in my brain over here, but then over here I'm like, ah yes, they need to be function definitions, but they don't actually need to be function definitions. They just need to be expressions. So grammatically, it's fine to have a I don't know if I want to allow grammatically all expressions there, but I do like the idea of adding labels in there. Because, like, it'd be kind of sketchy to have a function call in. Actually, no. If our generic system is functions, it might make sense to have a function call in there. I guess we just do expressions. All of them are expressions. Oh, this is function expression. We want pipeline expression, which takes in expression. Like so. Construct pipe not implemented. There we go. Alright then. So we have pipeline grammar now added. Something has come up that I should probably get to, so I'm going to end stream a little bit early today, but I go ham on code. No. I am happy with the progress I made so far. Wish I hadn't spent all my time on grammar, but is good. We now actually have a pipeline definition, and it's acceptable for now. I'll probably get this working off stream when I have the brain power to actually slog through the boilerplate that is going to be required to actually code that. Come on. Wow. Vim is very much lagging out right now. So we're just going to standalone process this. Streamline. Lose your grammar. Rework. Match. Grammar. Add pipeline grammar. Okay, and that is it for this stream. Thank you for watching. I will be back soon. Soon on the